One of the things that we want to be able to do is find the area underneath the curve. And the reason we want to do that is because an integral, that's really what it's asking for geometrically. So if this is the function x squared plus 1, this is called a definite integral because I have these numbers here. When there's no numbers, we call it an indefinite integral. So what this is saying geometrically, it says from 1 to 3, so let's look at this first picture. So I'm only looking at this graph from 1 to 3. I want to find the area underneath this curve. So I'm trying to figure out what this area is. So that's what the geometric representation of that integral symbol means when we have bounds. So later on, we will learn how to do it exactly. But for right now, the only way we're going to do it is we're going to do an approximation. Now, if this was not a curve, if this was a straight line, we have formulas from geometry that we could use to do that. But since this is a curve right here, we're going to just do an approximation using rectangles because we know how to find the area of a rectangle. So this is going to tell you how many rectangles that I use, and I'm going to tell you what type of rectangles to use. So this says we're going to use 2 rectangles. So that means the width of each rectangle is going to go is 1, right? We're going to go from 1 to 2 and then 2 to 3. And I'm going to say use right endpoint rectangles. What that means is these are the sides of your rectangle that you could possibly have, but we're going to hit the curve on the right side of this width. So the right side would be at 2, so this is where it hits the curve. So that means your rectangle goes straight across. So that's my first rectangle. Same thing with the second one. I'm going to hit it on the right x value, which is 3, and go straight across. So I can find the area of both of those rectangles right there, right? 1, 2, this is 5, and this I believe is 10. I mean, you also do have the function. So really, this is the y coordinate at 2. So f of 2 is 2 squared plus 1, which is 5. And then f of 3 is same thing, 3 squared plus 1, which is 10. So if you couldn't tell on a picture exactly where that y coordinate was, you could find it that way. So area is just length times width. So this is 5, this is 10. So the area using the 2 rectangles here would be 15. Okay? Now let's do the same thing, but this time let's say I ask you to use 4 rectangles. So that means I'm still going from 1 to 3. So that means the width of each rectangle is now only 0.5. So we're still going to use a right endpoint. So your rectangle is going to hit here. There's your first one, second one, third one. Okay, not exactly drawn to scale. There's your fourth one. So we want to be able to add up the areas of all those rectangles. So let's just go ahead and find the area of each piece separately. So this one here, area of the rectangle, its width is 1/2. And the height of this rectangle, that y value, exactly like we did here, would really be f of 1.5. Second rectangle, width is 1/2. This one, it hits it at 2, so that would be 1/2 f of 2. The next rectangle, width is 1/2 still, but the height hits it at f of 2.5. And the last rectangle, width is still 1/2, but notice the y value is going to hit it at 3, so it would be f of 3. And you can go ahead and use your calculator to do all this. It ends up being 12.75. Okay? Now, here are 2 questions I want you to think about. Is this an under or over approximation of the actual area? Well, obviously, there are parts of the rectangle that go over the curve, so this is an over approximation. The reason why the rectangles go over the curve is because you have an increasing function. So it's because this function is increasing. That's why when you use a right endpoint, it goes over. And notice, what did we do from the first picture to the second to get a better approximation? We created more rectangles. So the idea is, if I actually did the same problem using 100 rectangles, that would get you a better approximation, because this little piece that goes over the curve gets better and better. If I did infinite number of rectangles, that would be the way to get the exact area somehow. Okay, let's do the same problem, but let's do left-hand rectangles. And we're still going to do 2 rectangles on this one. So If I want to do left hand with this 1, I'm going to hit the curve on the left side. So notice it is f of 1. That's my first rectangle right there. The width of the second rectangle in this case is still 1. And then I'm going to hit it on the left side. So the left number between 2 and 3 is 2. So there's your second rectangle. And we need the y value at f of 2. So again, the function that we're looking at is this function. So f of 1, if I plug in 1 here, gives me 2. And then f of 2 here is 5. So this is 7. And notice here, this is an under approximation of the exact area because you're missing pieces, these pieces.